greatest. The greatest common factor. Do you guys remember doing GCF?
It's 4.
It's not 4. It is 5. 5 is the greatest common factor of 20 and 25. You guys remember doing that before? One X. What do you mean, how's it the greatest? So 4 and 5, the GCF of those is just 1. But they each have an X, so we can factor out an X, right? When we think about finding the GCF, what we're really doing is thinking about factoring that value out. Okay, so if I'm asked to find the GCF here with 3 terms, first look at the coefficients. For 12, 8, and 6, the GCF is 2. For x to the 5th, x to the 4th, and x to the 3rd, the GCF is x to the 3rd. It's not a division problem. It's something that is a factor of all of those things. So, if you think about prime factorization, because that's really what we're getting down to, 12 can be written as 2 times 2 times 3. You guys remember doing prime factorization? X to the 5th is x times x times x times x times x. Okay? 8x to the 4th is 2 times 2 times 2 times x times x times x times x. 6x to the 3rd would be 2 times 3 times x times x times x. So now what do they all have in common? They all have a 2. They all have an x, another x, and another x. So they have 2 times x times x times x, which is 2x to the 3rd.
So it's just the smallest. So how do you find that without
Yes.
finding out that?
So it is always the smallest exponent that all of the variables have in common. The thing that my algebra wants you to sort of understood last year, imagine this is 3 different terms, right? So imagine them as 3 buildings. I'm wanting to get to the highest floor on all of the buildings that they all have in common. So if the first building is x to the 5th, think about it, it is having 5 floors. X to the 4th has 4 floors. X to the 3rd has 3 floors. So what floor could I get to on all of them? I could get to the 3rd in all of them.
That makes sense.
I don't know if it does or doesn't, but I had to try over and over last year to try to get them to understand how to figure that out. But there's a couple of explanations for how to do it. Questions?
Is this it?
No. No, that is the introduction
Do you expect us
to this lesson.
No, I was like,
So now if I'm given this polynomial, and I'm told to factor it, if that's all it tells me, it's factor it. The very first thing I look for, every time I factor, number one, is there a GCF? Every time. So when I look here and I'm told to factor, is there a GCF? They just say yes and no over and over until you get the right answer. -3 is not the GCF. Is the GCF. -12, 18, and -27 all are divisible by 3. And they all have an x. So what's the highest power that they have in common? X to the first. Right? It's the highest floor they all could reach. So if I factor out a -3x from -12x cubed, what's left? +4 x squared. If I go ahead. Remember, x to the third is x times x times x. I only lost one of them. So x times x would still be x squared. If you remember, when we multiply, we add the exponents. Essentially, when you factor, you're dividing. So when you divide x to the third by x, you subtract the exponents. 3 minus 1 means there's 2 left. Or if you think about it as the buildings. If the first floor is the highest they can reach, and this one has 3 floors, there's 2 more left that one still has. Because it's subtracting. However you want to think about it. They all work the same way. Questions there? Next term, if I factor out a -3x from 18x squared. -6x. And if I factor out a -3x from -27x. +9.
How is it not X?
Because I already took the x out. This only had one x to give. I factored that x out here. One way you can always check if you did it correctly or not, think about distributing, which is what we just got done doing, right? If I distributed this back out, I should get what I started with. So if you had an x here, think about it. What would be -3x times 9x? That would be -27x squared. You didn't get back what you started with. Yeah, the other direction. That's what I told you when we went over it. I said we're fixing to learn how to go the other way.